You upgraded your embedding model, maybe from 384 dimension to 768 or 1536. You expected your rack system to suddenly become smarter, better answers, better retrieval. But nothing really changed. Or worse, result became unstable. So what's going on? Today I will show you why increasing embedding dimension doesn't fix retrieval and what actually determines retrieval quality. Most people assume this chain. More dimension means more information, which means better representation, which results into better retrieval. This sounds logical. If a vector has 1536 numbers instead of 384, surely it must encode more meaning, right? Not necessarily, because embedding size is capacity, not guaranteed signal. And retrieval fails for the reason that dimension doesn't solve. An embedding is just a coordinate system. Each dimension is a learned feature access. If your embedding is 1536 dimensional, that means the model can represent a meaning along 1536 directions. But here's the important part. Language itself doesn't necessarily need 1536 independent semantic directions. There is something called intrinsic dimensionality, which means minimum number of parameters or variables required to adequately describe a dataset or model without significant loss of information. So if the true semantic signal is say 100 dimensional, adding 1400 extra dimensions doesn't magically create new meaning. It just spreads same signal across more space. Let me show you something. Imagine we create a clean 10-dimensional semantic space. Each query has a correct matching document. Retrieval accuracy is almost perfect. Now we add 500 extra dimension of pure noise. No semantic information, just random values. What happens? Accuracy drops. Why? Because similarity now reflects noise as well as signal. The model doesn't know which dimension matters. This is what oversized embedding can behave like when the extra dimension don't encode the useful structure. Bigger space doesn't mean clear geometry. As dimension increases, signal grows slowly, noise grows linearly. Eventually, similarity metrics start reacting to noise instead of meaning. This is especially dangerous if your dataset is small, embeddings are not well normalized, domain mismatch exists. In those cases, larger embeddings can even make retrieval less stable. Retrieval quality depends more on alignment between query and document embeddings, training objective of the embedding model, domain similarity, and chunking strategy. If your chunks are bad, 1536 dimension won't save you. If your queries are poorly formed, dimension won't fix it. If your documents are too large or too small, similarity won't magically improve. Dimension is rarely the bottleneck. In high dimensions, distance concentrate. Vector becomes almost orthogonal. Some point become universal hubs, meaning nearest neighbor to many queries. So, instead of improving discrimination, high dimension can flatten similarity differences. Everything starts looking equally similar. That's not better retrieval, that's unstable retrieval. Here's something surprising. If you take 768 or 1536 dimension embeddings and reduce them to 200 dimension using PCA, retrieval performance often stays same. Sometimes it improves. This tells us something important. Effective dimension is often much lower than nominal dimension, which means extra dimensions were redundant. So the question arises, what actually improves the retrieval? Better chunking strategy, query rewriting, domain-specific embeddings, proper normalization, evaluating with recall at K or MRR, re-ranking with cross-encoder. These changes often improve retrieval far more than increasing embedding size. Embedding dimension increases capacity, but retrieval quality depends on the structure and alignment. If the underlying signal is weak, increasing dimensionality just gives the weakness more space. So before upgrading embedding, ask, is my chunking correct? Is my data clean? Is my embedding model trained for retrieval? Am I evaluating properly? If not, dimension won't help. Bigger embeddings are not useless. They make training easier, they increase flexibility, they provide representational capacity. But they are not shortcut to better retrieval. If this was useful, let me know. And in next video, I can break down how to properly evaluate embedding quality.